Okay, so let's see the exercise for today. We are going to use the cancer data again, and we want to build a data frame. And after that, we want to do a sample. So we are sampling 15% of the data set for the building model purpose. So we really have to do that. Otherwise, doing the grid search may take really a lot of time. So, well, this 15% and will guarantee that you can do the grid search. Well, even though the grid search might be on a very large range, and there's no problem for this one. And usually in the real projects, and especially your dataset is very large, and you may want to do something similar if you are using the full dataset for the grid search, and the grid search may take really long. So, well, this 15%, you may find I'm not keeping a lot of the samples, but this is to make this exercise quick enough for you guys. Okay, so and after that we select all the target, and then we keep all the features by dropping the target, and then we do the train and test split. And after that, well, this is your work. You have to do a grid search and with the c, the degree, and coefficient. And the kernel is, of course, the polynomial kernel. And you need to do a grid search and then try to find the best combination of the hyperparameters. And you may find something slightly different. Well, that is quite okay. And after that, you want to get the performance by sending the x test to the best model. And after that, you can do the classification report. And the next question is, if you want to extend the search space to do a next round of the grid search, and what will be the hyperparameters you are going to try. Okay, so first get your best combination of the parameters, and then think about this part. Do you want to try the second round of the search? And if you're doing that, what is the search space you're going to try? Okay, so go ahead and pause your video here, and well, later in the same video I'm going to show you my answers. Okay, so go ahead and pause your video here. Okay, so this is my answer key, and well, I'm creating a search grid with the C, and then the degree, the coefficient 0, and the kernel. I'm only trying the polynomial, and then I want to do a grid.fit with the x train and y train, and so I can get the best combination of the hyperparameters. And as you can see, so for the C, it is a 1. So C is 1, which is in the middle. So probably C equals 1, I can live with it. And for the degree is a 5. So degree is 5, which is the smallest number. So for the degree of polynomials, I may want to try something even smaller, like for example, 3 or 4. And for the coefficient, so for the coefficient, uh, it is a 10. So I think 10 is kind of a large enough coefficient. I don't want to try 50 or 100. So for the coefficient, if I stop at 10, I think I can go with that. Okay, so that's my observation based on my understanding of the hyperparameters. And the next part, let's take a look on the results. So for the result, it is, well, you can see for the testing data set, there are only, well, a little bit more than 2 dozens of the data. That's not a lot, but for the result, I would say the result is not so bad. Okay, so, well, if I want to do a smaller C, and of course I can try even smaller C, but as I said, you don't have to. And then for the degree, I'm going to try a few smaller numbers. And then for the coefficient, well, in my answer key I put that I want to try even smaller coefficient, but I will say, well, I think I can go with the coefficient as a 10. Well, however, it is okay if you argue that you want to try smaller coefficient. So this is my next round of the research, and after that, and I find the combination of a even better set of the hyperparameters. So this is quite common that when we are doing the grid search, we want to try a first round of the grid search. It is supposed to be a coarse grid search, and after that, if we want to go ahead and try the second round, we can narrow the search space a little bit and try the second round, and that is quite common. Okay, so a very quick sum up. We talk about the polynomial kernel today. So for polynomial kernel, this is one type of the kernel trick that the SVM model can do for us. Well, it works similar. It will give us the similar result as we add higher degree polynomial features, but without actually adding that many of the new features. And well, to find a good combination of the good combination of the hyperparameters, we do have to try to do a grid search, and usually a grid search, we do the first round, and then we narrow down the search space a little bit, and then we can try the second round of the grid search if that's necessary. Okay, so that's it for today, and thank you. Bye.